Hey guys, my name is Fritz Flores and I'm here to give all of you an introduction to chemical bonding. You can find this information in Chapter 6, Section 1. Alright, so first things first, let's start off with a warm-up question. How do you think compounds are formed? Remember, elements that react together form compounds. Their atoms join the other atoms through chemical bonds. For example, iron and sulfur react together to form a compound called iron sulfide. Another thing that's good to remember is that compounds usually have different properties from the elements they contain. Fun fact, noble gases do not usually form compounds. They are different from other elements because their atoms are described as stable or unreactive. They are stable because their outer electron shell is full. A full outer shell makes an atom more stable. Other elements react with each other in order to obtain full outer shells. Alright, let's get down to some basics. What is a chemical bond? Well, there are actually two types of chemical bonds. Number one would be ionic, and number two would be covalent. Two or more different chemically bonded chemical elements form a chemical substance. These have a fixed ratio determining the composition. The ratio of each element is usually expressed by chemical formula. For example, water, H2O, is a compound consisting of two hydrogen atoms bonded to an oxygen atom. The atoms within a compound can be held together by a variety of interactions, ranging from covalent bonds to ionic bonds. Bond polarities exist between the purely covalent bond and ionic bonds. For example, H2O is held together by polar covalent bonds. Sodium chloride would be an example of an ionic compound. Alright, let's go more into detail about ionic bonds. Make sure to keep your eye on this. Ionic bonding. Bonding that results from the electrical attraction between cations and anions. Here we have two examples. Example 1 would be sodium chloride, and example 2 would be magnesium oxide. In example 1, we have sodium and chloride. Sodium provides its electron to chloride, and chloride decides to keep it. In example 2, the same case occurs. Magnesium provides oxygen with an electron, and oxygen decides to keep it. Next up, we have covalent bonds. Covalent bonding results from the sharing of electrons between two atoms. There are two types of covalent bonds. We have nonpolar covalent and polar covalent. Nonpolar covalent has the bonding electrons shared equally by bonded atoms. This results in a balanced distribution of an electrical charge. On the other hand, we have polar covalent, which has the bonding atoms that have unequal attraction for shared electrons. Congratulations, you've made it to our checkpoint. Here's a question for you. What is the difference between ionic and covalent bonding? Remember how ionic bonds result from the electrical attraction between the cations and anions, while covalent bonding results from the sharing of electrons between two atoms. Next up, we have polar and nonpolar pairs. Oh wait, no, I mean bonds. Okay, so let's start with nonpolar covalent bonds. These have the following characteristics. The bonding of electrons are shared equally. There is balanced distribution of electrical charges, 0% to 5% ionic character, and electronegativity differences of 0 to 0.3. For example, if somebody asked you what is the difference between hydrogen and hydrogen, besides having a blank look on your face, you could tell them that since the difference is 0, it is considered to have a nonpolar covalent bond. Here's a quick tip. How to find the electronegativity differences. Basically, all you have to do is subtract the electronegativities. And last but not least, we have polar covalent bonds. These are bonded atoms that have unequal attraction for shared electrons. They also have electronegativities that differ greatly. Their ionic character can range from 5% to 50%, and their electronegativity have a difference of 0.3 to 1.7. For example, if you take hydrogen and chlorine, hydrogen is 2.1 and chlorine is 3.0. Subtract it and you get 0.9. Since the difference is more than 0.3, it is considered to have a polar covalent bond. Before you go, try to answer some of these review questions. Number 1. What is a chemical bond? Number 2. Why do most atoms form chemical bonds? Number 3. What's the difference between ionic and covalent bonds? Number 4. Define polar covalent and nonpolar covalent bonds. Alright, so that was an introduction to chemical bonding. My name is Fritz Flores, and I hope that was helpful.